Hey everybody, welcome back. We're moving into Module 3 and we're talking about descriptive statistics here. and, um, and so there's like two phrases that really sort of stand out to me at this point in the course. And one phrase is descriptive statistics and another phrase is inferential statistics. And so let's talk about inferential statistics first. So inferential statistics, I should just start saying stats, inferential stats. Inferential stats is stats where we have a population, and so let's say that population is all of the students at Fresno City College, like around 26,000 people, and we want to gain some information about that population. So we could either study the entire population, do some sort of a survey, and gain information about the population that way, gain data about the population that way. Or we could select a sample. And so we could select a sample of the population, and then that sample, like let's say we select 300 students or 500 students, and we gather data and information about those 300 or 500 students. So that sample is going to give us information about the population. So we'll make inferences about the population. We'll make inferences, inferential statistics. We'll make inferences about the population based upon the sample. So that's inferential statistics. And in inferential statistics, we're going to see this today. When we're talking about inferential statistics, we're going to have different notation based upon whether or not we're studying the population or whether we're studying the sample. So just as an instance, if we're studying a population, statisticians, in statistics, in stats, we're going to use the capital letter N to represent the number of people that we've studied in the population, or the number of items that were measured, the number of elements. And if it's the sample, we're going to use the lowercase n. Likewise, if we were to measure the mean of a population, we're going to use this symbol here, which is the Greek letter mu, mu. And if we're studying the mean of a sample, we're going to use x bar, an x with an x over it. So we'll use different notation based upon whether or not we're getting data and information about a population or about a sample. And if we're getting data and information about a sample, we're doing that so that we can make inferences about the population, and that is inferential statistics. So that's the first thing I want you to know, right? Like that's one of the, at this point in the course, there's two kind of phrases that stand out to me. The first one we talked about is inferential statistics. The next one we're going to talk about is descriptive statistics. And so in Module 2, we really looked at descriptive statistics, and that helped us, I'm just making sure I'm recording, looking at descriptive statistics helped us be able to describe what is occurring based upon the data and the information that we've collected. So descriptive statistics is really how do we take that data and how do we convey in a more descriptive way what is going on, what that data tells us. And just to illustrate this and to reinforce this concept about descriptive statistics, so we're learning about these phrases, inferential statistics and descriptive statistics. And just to reinforce these phrases, our understanding of inferential statistics, sample, making inferences about the population, and descriptive statistics, how do we more fully describe and convey what the data we've gathered is telling us? I want to show you this website, Gapminder.org. We may or may have not looked at this already. I just want to explore it again. I sometimes forget which class I've showed this to and which class I haven't showed it to. So a little bit of a reminder, but I showed this in my in-person class and it really drove the point home for students. So when you come here, you could go down to resources, I believe, and in resources, I'm looking for data. And so here we have data, and I'm going to go to, I'm just going to click on data and go there. And then here in data, right, when this pops up, it's populating, I'm going to go to GDP per capita. And right there you can see a little description of what GDP per capita shows us. And so GDP is gross domestic product, gross domestic product. And per capita is per person. I'm not sure why economists call it per capita as opposed to per person, but capita is person to economists. So GDP is gross domestic product, and per capita means per person. And so this is how much money a country makes. How much do they produce? What's their gross domestic in their country, domestic product, the amount that they produce, the product that they made per person. So a country will make a certain amount of stuff, it'll have a value to it, and then they'll divide that. Like let's say there's 10 people in our country and our country makes $100 worth of product, that's our gross domestic product, is $100. And actually let's say there's 5 people in our country. So $100 are the amount of product we made, the gross domestic product that we made in our country. $100 divided by the 5 people in our country, 100 divided by 5 is 20. So our gross domestic product would be $20, right, per person. Gross domestic product per capita would be $20. So there's a lot of terminology in stats. That's just the way it is. And to say it all becomes like a little bit of a tongue twister. And stats is partly about just becoming familiar and comfortable starting to use this terminology. And that terminology alone can be a little bit, take a little bit of time just to wrap your head around. So here's GDP per capita for different countries. So these are our different elements. These are our different observations, and they're for different years. And this is all data. Each individual piece of data is right there. And data, I was wondering about this earlier this morning, if the word data is both used for singular and plural. And so, sometimes the web, I'm looking for singular or plural. So I'm going to go to ChatGPT for this one. And I'm going to say, is the word data used for both singular and plural when talking about data? E.g., can data represent one item such as 7? And can the word data also represent multiple items such as 7, 8, 9, right? Let's see what ChatGPT has to say about that. And I like illustrating how I find answers so that, one, it kind of normalizes being human and how none of us know everything, including even myself. Geez, because I mean, it's kind of obvious when you state it, right? Because if I knew everything, like, wow, right? Like I would be like, I don't know, I'd be like God, right? I'd know everything. And, or whatever God you might subscribe to in your belief system. This idea of there being a God. I would be omniscient. I would know it all. And nobody is omniscient. We are all actually operating with a very limited amount of understanding, just to normalize this and to make us comfortable saying, I don't know. And becoming comfortable saying, I don't know is really important, particularly when you're young, because there could be this sense that you're supposed to have the answers. You come to school to find the answers, and faculty can often present it as if they have the answers because they want to seem like, what they've worked for in their life, is like they have a position and they got that position through hard work, and they do know some stuff. But really the truth of the matter is that everybody has multiple intelligences. So can you please explain multiple intelligences? Which means that I know some stuff that you don't know, and guess what? You know some stuff that I don't know, and actually the vast majority of us barely know anything compared to all of the information that is out there to be known. And to just really emphasize this point and to normalize how it's important to be able to recognize how little we all know and to be comfortable saying, I don't know, and to be in that position. And the reason it's important to be able to say, I don't know, is because you don't want to mislead people. You want to, when you say, I don't know, it puts you in a position where you're ready to learn. And in that position, right, like if you say, if you think you have all the answers, you're not ready to learn. But when you say, I don't know, then you could go ask questions and you're ready to learn. And so that's important all the way through your life. So multiple intelligences basically means you can pause the video and read it here, and then also pause the video and read it here, and then also pause the video and read it here, and then also pause the video and read it here. But multiple intelligences means that we all have things that we're smart and we know and smart about and that we know about, and we all have stuff that we don't know about. And the vast majority of humans actually have a tremendous amount of stuff they don't know. Like the amount we know is so vast compared to the amount we do know, and it's very limited. And just to illustrate this, please explain how humans don't know about, about dark matter and dark energy, which we know exists and which makes up about 95% of the mass in the universe or something like that. But we don't know what dark matter is and how we know nothing about it. Please explain that. Dark matter and dark energy are, dark energy are, and how we know nothing about them. I think I got a little bit of subject verb messed up in that, but close enough. Dark matter and dark energy are two of the biggest mysteries in modern astrophysics and cosmology. Despite making up about 95% of the total mass energy content of the universe, they remain largely unknown and poorly understood. So 95% of the total mass and energy in the universe we know nothing about. Like we're living in the 5% that we do know, which is extraordinary. So just being able to say I don't know is really important. All right. So data, right, getting back to this, we came here because I was like, hey, can data be used for singular or plural context? And the word data can be used both in singular and plural context. So this is data right here, that little 466, that's data. And then all of this right here is also data, and we'd also refer to this as the data set. And so I'm illustrating this because there's two phrases that really stand out to me at this point in the course. One phrase is inferential statistics. So we look at a sample to make inferences about the population. And the other phrase is descriptive statistics. And so now we're looking at understanding descriptive statistics. In Module 2, we looked at how we could use graphical displays, visual displays, to better describe what's going on with our data set, right? So to better describe what's going on, we looked at how we could use visual graphical displays in Module 2, histograms, bar charts, dot plots, scatter diagrams, and all that stuff. And in this chapter, we're going to start to look at how we could use different sort of numerical measures, different formulas, so that we could use those different numerical measures and different formulas to describe what's going on with our data, what's going on with our data set. And so I want to illustrate the importance of descriptive statistics here. And so here we have a data set. We have some data. And to make sense of this by looking at this is really kind of like, all right, so this is the GDP per capita for every country. And here are all the countries for each year. And it's also forecast out into the future. And so here we are right about, here, this is where we're at in time. Let me go back just a little bit more. So that's where we're at in time right there. And you can see all that data. And if you look through here, you could make decisions about where you might want to pursue a career. So pursuing a career, if you had the opportunity to work abroad, in Afghanistan, the GDP, the amount of money, the gross domestic product per capita that each person makes, the amount of money each person makes is $1,370 per year. But if you were to go to a country like Ireland, so let's go find Ireland. In Ireland, the amount of money each person in the country makes per year, the gross domestic product per capita is $116,000. So where would you rather work, right? Would you rather work where you can make $116,000 a year and bank a lot of that money, or would you rather work where you're barely making $1,500 a year? And so it also shows the disparity in income between different countries. Now, of course, in Afghanistan, you're $1,400 a year. Rent's going to be less, food's going to be less. And in Ireland, rent and food are going to be more. But this idea of going to an economy where you have the higher wage is a good idea. Like in California, you might want to go work in the Silicon Valley because the salaries are higher. And then after you've worked there for 20 years, you can move to Montana and you could sell your Silicon Valley house, which is like maybe 1,500 square feet, for millions of dollars and go to Montana and buy a ranch because there's different economies in Silicon Valley versus Montana. So this is GDP per capita. This is data. We're illustrating descriptive statistics. And this is kind of hard for us to assimilate as humans. And graphical displays help us assimilate that information more effectively. So if I go back to gapminder.org and I scroll down, we're going to be able to see a graphic display. Here in a moment it's going to come up. And on this graphic display, I want it to show me GDP per capita. And I'm going to make these smaller, GDP per capita, and we're going to call this wealth. Okay, it'll show us the wealth of nations. And I also want it to show us life expectancy, and we'll call this health. Okay, health. And then in addition, I want it to show us, every country. I want it to show us this for every country in the world. I want us to show us the population of the country. I want it to show us this data longitudinally. So that means over time, from 1800 to today. I want to be able to see how this has changed over time. And I also want to be able to see regions. How does this vary within regions? So we just looked at the data set, right, for the wealth of countries, GDP per capita. And I want to have some sort of graphical display. I want to create a descriptive statistical display of all of that data to better describe what's going on with not only this data, GDP per capita, but also for the wealth and the health of a country. I want to see that for every country. I want to see the population size of the country. I want to see how that's changed from 1800 till today. And I want to see the different regions of the world, the Americas, Africa and all the countries in Africa, Asia and all the countries in Asia, Europe and all the countries in Europe. I want to be able to see how are the different regions doing. And I want to just like assimilate that information. I want some way to describe all of this data, descriptive statistics. I want to be able to describe all this data visually and really visually sort of understand it. So there's this guy, Hans Rosling, and Hans Rosling passed away. And so here he is, and he's a Swedish physician and academic. He was a statistician, and this is what he looked like. And he wrote this book called Factfulness. And so Factfulness is his book right here. And what he found in this book was that we're living in the best time ever. The best time ever. And this corroborates, right? Define. This corroborates, I don't know how to say that word. I always want to kind of get it confused with collaborate. But it corroborates, and if I had speakers on this computer, which I don't, I could push this little microphone and tell me how to say it. I mean, I guess we could do it on my phone just so you could experience that. And I'm going to do, here in Google search, I'm going to say corroborate, define. And I'm going to look that up. I even had a hard time saying it here, but here you can see it on my phone, so I'm going to have it say it for us.
Corroborate.
Yeah, I guess that's how you say it. It just sounds weird to me. Corroborate. But this corroborates the work that was done by Steven Pinker. I think I'm saying that correctly. Steven Pinker, there you go, with a V. And so Steven Pinker is a professor at Harvard and a psychologist and psycholinguist. And he wrote a book called The Better Angels of Our Nature. He's like rocket smart. And the finding he found in The Better Angels of Our Nature is that humanity's doing better than ever. You've been born into the golden era, the golden age of the human race. Like there's never been a better time to be alive. And not only that, because you're taking this class, here from me at Fresno City College in California, you probably live in America and you've been born in one of the healthiest and wealthiest countries in the world currently. So you have greater wealth and greater health, greater life expectancy than most of the places in the world. And so you're in one of the best countries and one of the best times that have ever existed. Okay, so that's what Steven Pinker forwards in this book, Better Angels of Our Nature. That's also what Hans Rosling forwards in Factfulness. And just to show you that, to be able to take all of this data here and visually convey to you and just solidify for you and confirm for you that you are living in the best time ever, we're going to see a visual display that takes all this data and describes it more effectively, descriptive statistics. So we looked at what it looks like when we're just looking at this data here, where it's just a bunch of stuff like this. Here's what it's like when it's graphed out. Okay, so over down here we have GDP per capita on the horizontal axes, and over here we have health, we have life expectancy. So this is the wealth, GDP per capita, and the health of every country. And these balls each represent a country, and the size of the ball represents the population. And so here is China, pretty big, lots of people. Here's India, pretty big, lots of people. Here's the USA, not as big as China and India. But you could see when I hover over that in the United States, down on the x-axis, if you live in the USA, you're going to make $64,700 a year, kind of, the average salary. That's the GDP per capita. You know, like if you look at all the money America made divided by the population, this is how much money per person is made, GDP per capita. And you're going to live to 78 years. That's your life expectancy. That's your health. So you could see that for every country. And you could sort of see the lay of the land. And over here you have regions. So if I hover my mouse over green, the green balls, the green countries start flashing. And you could see in the Americas, like, you know, how are the Americas doing, this region of the world? What's their health and wealth? And here's where Africa is. Like, Africa is not doing as well as the other countries. Some of the countries in Africa are doing okay. And if you come over here, you can see them. Hard to get to some of them because they're on other balls. There we go. So Egypt is doing well. South Africa is doing well. Botswana, right? And Equatorial Guinea and Algeria. And there's one right there. Libya. And then there's one more right here. Mauritius, however you say that, right? Like, you know, if you live in Mauritius, let's see where you're at if you live in Mauritius. There we go. You're making $22.8 thousand a year and you're living to 74.3. So you could see these different items. You could see the health, you could see the wealth, you could see the country, you could see the population, you could see the regions, right? So whether it's the Americas or Africa or Europe or Asia over here. But what we haven't seen yet is how do we see this over time? So down here we have this playhead. You can see this is 2022. But if we scrub this playhead, we see these balls change over time. And here we have a history of humanity over the last 200 years. This is an incredible using descriptive statistics, taking data, stuff that was like this, and turning it into stuff that's like this. This makes this data here much more accessible. It's like, oh, I get it. Look at what's going on with humanity. We're living longer, and we're healthier, and we're wealthier than ever. And you can see this over time. And it's interesting because like here in 1917, all the balls are going to drop. And so you could go to ChatGPT and you could say, what happened in 1970? What happened in 1917 that so, whoops, not 1017, 1917 that so many people died? Was it only World War I? I don't know why you put an I instead of a 1. Was it only World War I? Or, boom, we'll put the I. Or was there also some pandemic? I think there might have been like a flu or something that killed a lot of people. Significant number of deaths were primarily due to World War I. However, the Spanish flu pandemic, which was another major cause of death, did not begin until 1918. 1917 itself is marked mainly by the ongoing devastation of World War I. The pandemic, though, had followed in 1918, compounded the global loss of life. So this drop in population in 1970, right, boom, that's the war. Boom, boom, right? That's crazy, man. That's the war. World War I, all those people died. It was a big war. Look, people from everywhere were going to die. That's nuts. All right, and then, you know, it kind of makes me think that maybe the data there is also the pandemic because it's everywhere. Like, why did some of those countries, like, they're just too far away from Europe to have been involved and everything's dropping. So I think also the pandemic. But we also see a big loss of life here in World War II. So starting in the 40s, you see the balls drop again. So life expectancy really going down. Lots of people died. And then after post-World War II, we've been in this golden era, this golden age of humanity. You're going to see health and wealth just like skyrocket. And way out here, you have USA, and you're going to see India and China really come from behind post-World War II and move forward in health and wealth. And their population grows, and then they move forward, and this is where we are today. Pretty incredible. So that's descriptive statistics. At this point in the course, right, what kind of stands out to me is there's these two phrases, inferential statistics, where we're talking about sample and a population, and descriptive statistics, where we're taking data and data sets like this, and trying to make it more descriptive. In the previous module, we looked at how to do that visually with charts and graphs of various types, including like this, which is extraordinary. And in this module, module 3, we're going to look at how to do that not visually, but numerically with different formulas. So we're going to see how to use different formulas and different measures to start telling ourselves stuff about the data. We'll do that in the upcoming videos.